Connection of LTI systems as shown in following figure. X of n and h1 of n, h2 of n, h3 of n, h4 of n, y of n, and we have a minus sign. All impulse response in terms of h1 of n, h2 of n, h3 of n, and h4 of n. Now let's see how to do this. First of all, when we do this, you have to know one thing, that if you have these blocks, if it's in, well, let me write here. So if you have these blocks, if it's in parallel, that's going to be added. If it's in parallel, it's added. If it's in a series like this, it's convoluted. Okay, so you have to know that if it's in parallel, it's added. If it's in series, it's convoluted. That's all we have to know in order to express the h of n. H of n is basically how we express the whole system using all these terms. Okay, now let's go ahead and do that. If I say h of n, now let's look at the easiest one. If you see, the easiest one to figure out is h3 of n and h4 of n. Both of them are in series, so we can just go ahead and convolute them. h3 of n convoluted with h4 of n. Okay, now when we convoluted, we can consider these as one thing, and if you look at this one, it's parallel to this. So we know that when we have something in parallel, we have to add. So we put h2 of n, and we have to add that one with these two. But when we add, we have to make sure what we have to look at what sign we have. If it's a minus, we put a minus here. Okay, and then the next one is now we combined all of these three are taken care of. Now these three are in series with h of n, so we have to convolute that. Okay, h1 of n, we have to convolute the whole thing with h1 of n, and that is the expression for the h of n. H of n is basically h1 of n convoluted with the whole thing, and then h3 and h4 are convoluted, and h2 minus this one because of these two are in parallel. Okay, so now that's the A part of this. Let's look at the B part of this. In the B part, they are saying determine h of n when h1 of n is 0.5, 0.25, 0.5, and h2 of n, h3 of n is equal to n plus 1 u of n, and h4 of n is equal to delta of n minus 2. Okay, so let's see how to do that. Now in order to do this one, we are using this equation, but we can go one by one. Like we can take this h3 of n, h4 of n convolution alone and do that first, then we can subtract after, and so on. Okay, so if I just take the h3 of n, h4 of n convolution, h3 of n convoluted with h4 of n, we know that h3 of n is given by n plus 1 u of n, n plus 1 u of n, and then h4 of n is nothing but delta of n minus 2. Convolute this one with delta of n minus 2. So when you convolute some function with delta with a shift, what will happen is, according to the convolution property, the shift of the delta will be replaced with all the n, and the delta will disappear. So here what will happen is this shift will happen here. So here we'll have n minus 2 plus 1, and also in the u of n we'll have the shift u of n minus 2, and n minus 2 plus 1 we can combine and make it as n minus 1. Okay, and then here this is u of n minus 2 remains the same. Okay, so now we have the expression for the h3 of n convoluted with h4 of n. This is the one we have. Now the next thing is we can do is we can do this h2 of n minus h3 of n convoluted with h4 of n, h3 of n, h4 of n convoluted. We have the expression here. We have to just subtract this one from this h2 of n and see what happens. So maybe I go to the next page, but I bring this expression to the next page as well. So we have the h3 of n, h4 of n convoluted, we just derived. h4 of n convoluted, and that is equivalent to n minus 1 u of n minus 2. Okay, so we have this expression. Now the next thing is we can subtract this one from h2 of n. h2 of n is nothing but n plus 1 u of n. So if we say h2 of n minus h3 of n convoluted with h4 of n, then we know that h2 of n is nothing but n plus 1 u of n. U of n, and that one minus this thing h3 of n convoluted with h4 of n, which is n minus 1 u of n minus 2. Okay, now let's see how we can simplify this one. In order to simplify this one, what we can do is we can put it in a graph. That's one way to simplify. So if we put it in the graph, we have to know one thing, that if it's u of n, it's going to be just a continuously happening. It start from 0 and it keep on going continuously, and based on the amplitude it will increase. So here if it's u of n, for example, if it's u of n, u of 0, at 0 it's 1. Okay, at 0 the height is 1, but as it goes further, like when u of 1, the amplitude increases by 1 each time. Like when u of 1, this is going to be 1 plus 1, then this height is going to be 2. Okay, because since the expression is given as n, as the u of n increase, then this n also increases. So it means it goes like 2 there, and then when it's 2 it goes 3, and so on. Okay, so that's gonna keep on going, keep on increasing and going forever. And we are subtracting that one with minus. So if it's minus, it's gonna go down. The next graph is gonna go down, and it's starting from n minus 1. In n minus 1 mean okay, before that I look at this one, n minus 2 here. This unit step function starting from 2 units to the right, so it means it's going to be starting from 2, and it's going to be downward because of this minus sign. And initially n minus 2, so initially let's say start from 1 minus 1. Okay, because unit step function always begin with a 1, and as it goes further, so for this one, like we had to consider, like this is a u of 0, like 0 location, the first location for this, that is 1, and as it goes further it decreases. So it means it's gonna decrease, keep on decreasing. It means going down further and further, like by 1 unit each time. So it's gonna be minus 2 when it's 3, and then minus 4 when it's 4, and then minus 3 when it's 4, and so on. Okay, now if you look at the relationship, so here as it 3, this is minus 1. So if you combine both of them, if you add both of them, 3 minus 1, that's going to be 2. And if you look at this one, this height, if you keep on going for the upper graph, it's going to be like 4 next one, because it's increasing by 1 each time. So 4 minus 2, 2. As you calculate each of them, everything gonna combine into 2 only. So the combination of these two graphs is going to be nothing but, initially at the origin it's going to be just 1, the height is going to be 1, but as it goes further, it's going to be keep on repeating 2. It's going to be 2 all the time. Okay, so now we have to just write the expression for this, and that's going to be this one. We can use the graph like this to simplify the expression. Now if we find the expression for this graph, that's going to be the equivalent expression for this one. Okay, now for this one, what you can say is the unit step function, for the unit step function, the height is 1. So if we say 2u of n, then the height becomes 2 because of this amplitude. Then we have to subtract 1 from the origin, because at the origin the height is only 1. Yeah, after the origin is 2, but at the origin is 1. So to make that one 1, we can just put delta of n. This n represents n at 0. So the height of the delta function is just 1. So if we subtract 1 from the first one, like it's always 2 from this, like when we have this expression, it's 2 here, but after we do subtraction, it become 1 at the origin, because the delta function happen only the particular point, like this is like n at 0, so this only happen at this point and we are subtracting it, so it's gonna remove one of this, the others remain the same. Okay, so this is the equivalent expression for this one. You can also say this is equal to 2 u of n minus delta of n. Okay, but our final purpose is we have to derive this expression. Okay, we have to derive this expression in terms of these terms. We have taken care up until this point. Now we have to convolute that one with h1 of n, and h1 of n is given by 0 0.5, 0 0.25, 0 0.5, and here I have to make a correction. We have to know that this is at the origin. Okay, we put arrow like that saying that this is at 0. Okay, so now we grab this one and do the convolution with h1 of n. So we have the expression for the, let's rewrite it, h2 of n minus h3 of n convoluted with h4 of n h4 of n, and that is equal to 2 u of n delta of n minus delta of n. And now what we have to do is we have to convolute this whole thing with h1 of n. That's the final answer, because we know that h of n is nothing but h1 of n convoluted with the whole thing h2 of n minus h3 of n convoluted with h4 of n. Okay, so let's do this. h1 of n, let's write the h1 of n. h1 of n is given by 0 0.5, 0 0.25, 0 0.5, 0 0.5, 0 0.25, 0 0.5, and the 0 0.5 is at the origin. The others are like this. Now what we do is we do the convolution. So the expression after we put this will be like this: h of n, that is equal to 0 0.5, 0 0.25, 0 0.5, that is convoluted with 2 u of n minus delta of n. Okay, so when we do the convolution, it's like we just multiply each time. So 2 times u of n times 0 0.5, that's going to make it to multiply 2 by a half. That's going to be just u of n. So we are going to get u of n here and then u of n here, and then 0.25 times u 2, so this is like 1 over 4 times 2 u of n, which is going to be 1 over 2 u of n minus 1, because this is at the origin, that's a u of n. So this is going to be u of n minus 1 because it's moved 1 unit to the right. Okay, okay. So we put this one 1 over 4 times 2 u of n, which is equivalent to 1 over 2 u of n minus 1. Okay, and the next one is, I have to keep on putting plus. The next one is 0.5 to u of n. So this is like 1 over 2 times 2, 2 cancels. But this is at u of n minus 2 because 2 units are right. So I shouldn't close the bracket yet. Okay, that's bracket for this one, n minus 1. So this is going to be u of n minus 2. Okay, so that is this. And then we have minus sign because of this minus. And then delta of n, we do the same. 0.5 delta of n, 0.5 delta of n. And then plus 0.25 delta of n, 0.25 delta of n. We can also say 1 over 4 delta of n. Actually delta of n minus 1, because this is at the location of n minus 1. And then plus 0.5 delta of n, that's going to be 0.5 delta of n because of this 2 unit to the right. It's going to be 0.5 delta of n minus 2. I put it in the downside because I don't have, maybe I put the whole thing together. Plus 0.5 delta of n minus 2. Now we have to subtract. Okay, so we have to subtract each location. Like if it's u of n and delta of n, what we can do is if we combine both of them, like if you, this is like 1 here, 0.5, so 1 minus 0.5, that is 0.5. Now the question is whether to put u of n or delta of n. Better to put delta of n because delta of n is basically happening only at the particular location. Okay, u of n mean continuous, so we are taking each point until the points available to us, and after that we can express u of n. U of n mean we are expressing as continuous. So this is 0.5 delta of n because 1 minus 0.5, that is 0.5 delta of n. And then we go to the next term. At n minus 1, what's happening? We have a half u of n minus 1. Okay, and here we have to be careful because of this u of n. This u of n is going to keep on going forever. Like there's no end for this. Like it's going to start from 0 and goes forever, and that is going to add up with this one as well. So here we have half, and this one going to add up with this one. So this is 1.5 at n minus 1, and this delta of n minus 1 is the impulse function. It's only occur at a certain point, so it doesn't continue, so we don't have to care about what is we had previously. So what we do is 1.5 minus 1 over 4. So that's like 3 over 2 minus 1 over 4. 6 over 4 minus 1 over 4. That is 5 over 4 minus 5 over 4, or delta of n minus 1. And that is after we subtract. So it's going to be plus. Okay. And the next thing is we are going for this. Now this is like 1 here, but all the previous u of n function is going to affect because this unit step function is continuous forever. So here this 1 amplitude comes up, this 0.5 amplitude comes up, and then this one. So 1.5 plus 1, 2.5. 2.5 minus 0.5 here. That's going to make it 2. So we're going to have plus 2 delta of n minus 2. And then the last one, like after we taking care of all the points, now we can last one we can express as u of n, because there's nothing to subtract or add or anything after this. So we can express the last one as u of n, and the last one is going to be 1 plus 0.5 plus 1 again, so totally 2.5. We don't have anything to subtract in the n minus 3, which means the 2.5 amplitude is going to go forever after this. So it's going to be like plus 2.5, or you can say 5 over 2 as well if you want. 5 over 2 and u of n minus 3. Okay, and that's the final expression. That is the h of n. H of n expression. That is after we convolute all this, we calculate the value and finally bring to this one. Okay, that's the B part of this. And the C part is asking, determine the response of the system in part B if x of n delta of n plus 2 plus delta of n minus 1 minus 4 delta of n minus 3. Okay, so the question is asking response of the system. The response of the system is given by B part I'm doing y of n, which is x of n convoluted with h of n. For the h of n, we derive the expression right here, and x of n, they have given it over here in the question. Delta of n plus 2, 3 delta of n minus 1, minus 4 delta n minus 3. So what we have to do is we have to bring this term and convolute it with this one. Okay, and for the x of n, if you notice, we can also write this one as a values, like delta function occurs at a particular point. Like if it's n plus 2, then 2 unit to the right, so it's gonna occur at minus 2. At minus 2, the height is gonna be just 1, because we don't have any other amplitude here. So we can just say 1 here, and then that is at minus 2. If you look at the next point is occurring at 3. Actually, sorry, n minus 1. So that is 1 unit to the right. So until 1 unit to the right, we don't have anything. So others are going to be 0. So this is occurs at minus 2. Then minus 1 is going to be 0. At 0 is going to be 0. We put an arrow sign to represent this is our 0 location. So at 0 is 0. At positive 1, we have this one right here. At positive 1, we have 3. So we put a 3 for it. And then positive 2, we don't have anything. Positive 3, we have a minus 4 amplitude. Positive 3, we don't have anything, so put a 0, and then minus 4. Okay, if you write in this way for the x of n, it will be easier to do the convolution, because when we do the convolution, we have to just take care of the points, or the parts where the points exist. That is this 1, 3, minus 4, and then when we convolute, we just multiply the other one by each terms. Like now I can do the convolution of h of n, which is the expression I derive here. That is 0.5 delta of n. So I can just copy paste it here. Okay, so I copy pasted it here. So now what we do is we multiply each time and then add them together. So 1 times 0, so the first term is going to remain the same because we are multiplying everything by 1. So we are going to end up having this one 0.5 delta of n plus 5 over 4 delta of n minus 1, and then plus 2 delta of n minus 2, then 5 over 2 u n minus 3. Okay, so that's the first term is gonna, then we add the next one plus 3, then we multiply everything by 3, so 3 times 0.5, So that is like 3 by 2 delta of n, and then 3 times 5 over 4, which is 15 over 4 delta of n minus 1, and then 3 times 2 delta of n minus 2, which is 6 delta of n minus 2, and then 3 times 5 over 2 u of n minus 3, which is 15 over 2 u of n minus 3. Okay, then lastly we multiply everything by minus 4, so everything's going to be minus minus 4 times 0.5, which is going to be minus 2 delta of n, and then minus 4 times this, 4 cancels, so we're going to get minus 5 delta of n minus 1, and then minus 4 times 2, that's minus 8 delta of n minus 2, and then minus 4 times 5 plus 5 over 2, which is minus 2 times 5, which is minus 10 u of n minus 3. Okay, so this is going to be the expression. Okay, let me double check if I'm doing any mistake. Yeah, there's another thing I didn't consider. Because of this one occurring at minus 1, when we convolute, the location also are going to affect. So this is like 1 unit to the right each time. So this is going to become n minus 1 here. Okay, and then this is going to be n minus 2. We have to just subtract 1 and everything. So this is going to be n minus 3. This is going to be n minus 4. And we have to look at this one as well. This is 1, 2, 3 units to the right. So we have to subtract 3 each time. So this is going to be n minus 3. And then 3 minus 3 minus 1 minus 4. And then this one is minus 2 minus 3, which is minus 5. This is minus 6. Okay, so we have to take care of the location as well. And this is how it's gonna look like. Now from the expression we can try to simplify by plotting the points. So I can do this in the next page, and I bring this one to the next page, because we can plot the graph and try to simplify this one. Okay, so delta of n mean that is at 0 origin. The height is 0.5, which is like this. So this is just the height is half, and then 1 unit to the right we have the height 5 over 4. Is 5 over 4 bigger than the 1 over 2? Yes. No. 5 over 4 is equivalent to what? 5 over 2 is 2.5. 1.25. So that's going to be higher than this. And then so this is 1. At 2 we have the height of 2, and at 3 we have the height of 5 over 2. 5 over 2. So that is for this one. And if we go to the next one, at 1 we have 3 by 2 height, Yeah, when I do the convolution, I think I made a mistake. Yeah, I didn't consider this location as well. Like this is like 2 location to the left. So for this one, we have to add 2 each time. So which means this is +2 here, and this one is if I add -1 +2, which is +1, and this is going to be 0. So delta of n, and this is if I add +2, this 1. Okay, I didn't consider first point. So it's going to be different. So I copy again. I'm going to erase this one. Okay, let me erase this one. Yeah. Um. Hmm. So I had to re-draw everything because that was a mistake before. Okay. So if I start with n plus 2, so this is like -2 here. That is, the height is 0.5. And then n plus 1, that's at -1. The height is 5/4. And then at 0, the height is 2. At 1, the height is 2.5. And then 1 unit okay, so this 2.5 is going to continue forever because of this is a unit step function. So we can put a dot dot online like this to represent its continuous. And then we also have another height of 3/2 at the same location. Let's use a different color to express that. So 3/4 is like 1.5, something like here. 3/2. And that is at this, and then 15/4, which is equivalent to 3.75. That is happening at 2. 15/4. At 3, the height is 6. At 4, the height is like 7.5. 7.5, and then 3 units is right. We have minus here. Let's use a different color. So the amplitude is 2 right now, but is downward. And then at 4, we have the amplitude 5 here. And then at 5, we have 8 downward. And then at 6, we have 10 downward. Okay, so this is the final expression. And the last ones, we have to put a unit step function. So this 7.5 keep on going forever. So I put a dot line for this, and this one also goes forever until the last point. I can try to simplify this one in expressions like delta functions and unit step function. So if I say y of n, then first point we don't have any effect, so we can put half delta of n plus 2 as it is. And then the second point also doesn't have any effect, so that is 5/4 delta of n plus 1. And the third one also doesn't have any effect, so we put the height is 2, so 2 delta of n. And the fourth point, we have some effect. We have a unit step function that is height is 2.5 going forever, but we have a 3/2 at the same location. That is only happening at the location. So what we can do is we can combine these two together. So 2.5 plus 3/2, which is 1.5. So this is 3, 4. So we're going to have the height of 4. Okay, so 4 at here. And we can just express the delta of n function, because we can keep on doing until this point. So I just look at this location only. So I put delta of n here. 4 delta of n minus 1. And the next point, I have 15/4, which is equivalent to like 3.75. But at the same time, this unit step function is going to affect here as well. So like that's like 5/2 plus 15/4. So that is like 10/4 plus 15/4, which is 25/4. Okay. 25/4 delta of n minus 2. And then if I go to the next one, I have a 6 here and a 2 downward. So 6 minus 2, that is 4. And then 4 also, and also this unit step function affecting here. So 4 plus 2.5, which is 6.5. I can also say 13/2 as well. So 13/2 delta of n minus 3. And if I go to the next one, we have 7.5 here, and we have 2.5. So this is going to make it to 10, and 10 minus 5, that's going to be 5. So here we're going to have 5 delta of n minus 4. And then here, so we have taken care of minus 4, that is over here. Then if we go to this one, here we have a unit step function affecting and another unit step function affecting, so totally 10. 10 minus 8 here, which is 10 minus 8 is 2. So we're going to have 2 delta of n minus 5. Okay, and then if we go to the next one, we have a unit step function here, that is the height is 2.5, and then another one 7.5, so totally 10. 10 minus 10, that's going to be 0. So that's going to be 0, and it's repeating again and again. So the next points are going to be just zeros. So plus 0 plus 0 plus 0. So it's going to keep on, so until this point only what matters. Now since we don't have final the unit step function are cancelling each out. So only up until this point only what matters, and we can also express as points only. Like if we just take the amplitude of each one, then we are going to have, let me use a different color so that will be very visible. If I just take the amplitude, that's going to be, let me, so that I can clearly see. Okay, so if I just take the amplitude, this is going to be half first, and then 5/4 second. Okay, we can also say y of n is equal to all this. Let me rewrite it. y of n, that is equivalent to, if I take the amplitude of the first one, that's half, and then the second one is 5/4, and then the 2, this is at 0, so we put arrow sign so it's at the origin, and then we have 4, and then 25/4, and then we have 13/2, and then we have 5, and then 2. And if we express this one, that's it, and the others are 0, we can also just put it, but we can put a dot line, say it's given be 0 after that. Okay, so this is the final expression, and that is it for this video. I hope you guys found this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.